A very good morning, class. In lecture number 4 of chapter DNF block elements, unit 8, we are going to, we have done already with that, what are D block elements, what are their physical properties, chemical properties, whatever the properties are there, whatever the elements are there. So that already we have done. So now we are doing that, we are going to do that formation of color complexes, how they form the colored complexes and how they form complexes, so that we are going to understand. So formation of colored complexes or colored compound, as transition elements have unpaired electron, so they absorb radiation from visible range and show DD transition. This is the very important line. If you are not learning all this point, or you are not able to get this point, so let it be, you just write this, because they are able to show DD transition, and that's why they impart color. That will give you like half marks at least of that question, whatever. Yes. So if you are mentioning all the part that because of this unpaired electron, they absorb the radiation from visible range and go to higher state, and when they come back, due to that they show DD transition, and hence they impart color. So that is the full explanation for that. In that, when an electron from a lower energy d orbital is excited to higher energy d orbital, lower energy say that it absorbs the energy and it goes to higher energy d orbital. The energy of excitation corresponds to the frequency of light absorbed, and this frequency absorbed generally lies in the visible range, and that is the reason that they give color. So this frequency of light that is absorbed by is determined by nature of ligand, size of metal ion, and oxidation state of metal. Okay. So these are the three factors by which we can decide that what type of frequency it is going to be absorbed. It is absorbed. Okay. So they're the transition metals color, ion color, how they will show the color, what color they will have. So in out of this one is the very important compound, manganese. That is +7, it will be dark pink, and +2 state it will be light pink. So you people have done titration. If in the lab you might got this point. Okay, whenever we start the titration, we get the dark pink color, and at the end point we get the light pink color, because Mn+7 goes to Mn+2 as it acts as the oxidizing agent. Yes. Similarly, iron, that will show in the +2 state it will be greenish in color, while in the +3 state it will be brownish or yellowish, you can say that. Yes. So this is again important one. Next is chromium. That is again question will be asked from this chromium part. So just be clear with this. It shows 3 state, +2, +3, +6. Out of that, +3 and +6 jo hota hai, that is important one. Okay. So in +6 state, it gives the orange color. Okay. And while in the +3 state, it becomes green color. +2 state, it will show you the blue color. That is little rare. Okay. It won't be asked in that. So color changes पूछा जाता है कि like orange color substance, when it reacts with something, so it converted into the green color substance. So what this compound can be used in the detection of alcohol test also. So that can be asked. So you have to learn that orange color किसका होता है and green color किसका होता है, dark green. Okay. Copper, everyone is aware about this. Copper +2 state, it is blue in color. Yes. Nickel is that lightest greenish, you can say that, light green color. Cobalt is pinkish in color. These are not so important, but if you can learn it, it will be better. Yes. So this compound, manganese, iron, and chromium, as I told you, these are the important one. Okay. So now let's do this. Transition metals form colored compounds and complexes. These colors can vary depending on the charge on the metal ion. Depends upon the oxidation state, as I have told you right now. Yes. Depending on the charge on the metal ion and the number and type of group of atoms, that is called ligand, attached to the metal ion. In aqueous solution, the ions form complexes with the color shown to the right. Yes, these are the color shown by the element. Okay, so just go through with these points that transition metals form colored compounds and complexes. These color can vary depending on the charge on the metal ion and the number and type of group of atoms that is called ligand. So right now I have told you when it will show +2 which color, +7 which color, like this also we have done. Yes, aqueous solution ligand attached to the metal ion. In aqueous solution, the ion form complexes with the color shown to the right. Like this is the color. These color they can show in the aqueous solution only. Okay, not in the dry condition or anhydrous condition. Electrons are arranged around the nucleus of the metal atom in orbitals. Transition metals, unlike other metals, have partially filled d orbital that we know. We are very much aware about it. Yes. Other metals have partially filled d orbitals, which can hold up to the 10 electrons. When ligands are present, some d orbitals become higher higher in energy than before, and some become lower because of ligands. They show high spin complex or low spin complex. We know that. Yes. Electrons can then move between these higher and lower d orbitals by absorbing a photon of light. These absorption of light affect the perceived color of the compound or complexes. The wavelength of light absorbed is affected by the size of the energy gap between the d orbital, which is in turn affected by the type of ligand and the charge on the metal ion. So that is basically right now for this time being you have to learn that they show different oxidation, they show different color in different oxidation state, and that also depend upon the number or type of ligands, whether they are forming high orbital complexes, that means we can say that low weak ligand, or they form low spin complexes, that means strong ligands. So in that case it will all these things will decide the color of the transition elements. Okay, this is another slide for the same color. We can see that Mn+2 pink color. We are very much familiar with this. Chromium +3 green. Nickel +2 is also green. CrO4 -2. That means here it is in which state? Just find the oxidation state. It is +6. So +6 means it will be yellow. Or somewhat it is here Cr2O7 here also +7. So these are the two +6 +6. But if it is chromate, it will be yellow in color, and if it is dichromate, it will be orange in color. Got it? Similarly, MnO4 potassium permanganate will be purple, dark purple, and this is Mn+2 will be in pink. Fe+2 green, Fe+2 3 brown, Cu+2 blue, and Cu+2 black, pink. So these are the color. Okay, chaliye. Now formation of complex compounds. As they have availability of d orbital, so they can form complex compounds with anions or neutral molecules as ligand with the coordinate bond. Since they have availability of d orbital, they have d orbitals, and hence they can easily form the complex compound with the anions or the neutral molecules which with the help of coordinate bond, and these anions and the neutral molecules are called ligands. Yes. Example where we have seen in that like coordination compounds, FeCN6 -3, tetraamine copper +2 here, this is tetra aqua manganese +2, this is tetrachloro copper +2. Yes, so these are the some examples how they form, that we are going to some more properties. Catalytic properties. Due to availability of d orbitals, transition elements can show multiple oxidation state. Here again, due to the availability of d orbital, they were supposed to form complex compounds. Now catalytic property is also due to the availability of d orbital. Transition elements can show multiple oxidation state and hence can form complexes, and hence can show catalytic properties also. Got it? Because of they have d orbital, they can show multiple oxidation state, and hence they can form different complexes, and that's why they show different catalytic properties also. Example, V2O5 in contact process. Contact process is used to prepare H2SO4, sulfuric acid, on the larger scale on industrial stage. Yes, so there the V2O5 is used as a catalytic properties, which is made up of vanadium, and vanadium is a transition element. Finely divided iron, that is Haber's process. Haber process is used for formation of ammonia, and there we use Fe in presence of molybdenum. So both are transition elements. Yes. Ni in catalytic reduction we have already done in even in class 10th also. This is called hydrogenation. So that we can do in presence of nickel, platinum or palladium, and all three are transition elements. Fe plus 3 that also act as a catalyst, and that catalyzes the reaction between iodide and persulfate ion. This is a type of titration which is called iodometry. Yes, so that is not in our syllabus, but in extra, if you want to learn it, we can go through with this. Yes, in the next slide, further slides. Okay, now like this is 2I minus plus S2O8 minus 2. It is going to convert into iodine minus, here it will be oxidized in I2, and S2O8 will be reduced in SO4 minus 2. Okay, so this is Fe here act as a catalyst. The mechanism is 2Fe plus 3 will react with this 2I minus, will give you Fe plus 2 and I2. Further, this Fe plus 2 जो बना, that is going to react with this 2. Again, we'll get this Fe3 back, and this will convert into SO4. Now, add both the equation and you'll get the previous one. Got it? So this is the reaction in that this Fe जो है, वो worked as a catalyst. Final product, if you'll see that Fe will not be there, Fe will be cancelled. So catalytic properties का यही होता है that it will not change itself, isn't it? Okay, so actually Fe plus 3 oxidizes I minus 2 iodine, and hence Fe work as a catalyst. Now these are some process where we can use the transition metals as catalyst. Like here it is Haber's process. Iron is used to form ammonia. Now contact process, this is 2SO2 plus O2 will give you SO3, and here the vanadium pentoxide is used as a catalyst. This is the main step for the contact process. Next, biological enzyme की तरफ हम use होता है. This is hemoglobin, and we know that hemoglobin is a coordination compound of iron, which is a transition elements. Next, vitamin B12 also we have done this in the coordination complex. This is RBC production, it helps, and this is a complex of cobalt. This is hydrogenation. We know that conversion of vegetable oil to vegetable ghee. This is used H2 in presence of NiPT or PD. So like this. This is catalytic converter, conversion of CO2 and N2. When this carbon monoxide and nitrogen oxide reacts, it gives carbon dioxide and N2. There the platinum or palladium as catalyst is used. Next is hydrogen peroxide decomposition in to give oxygen, and here the manganese oxide Mn4, yes, that is used as a catalyst. MnO2 is used as a catalyst. Now next, formation of interstitial compound. That transition elements form interstitial compound when small atoms like carbon, hydrogen, nitrogen are trapped inside the crystal lattice of metals. Few like a small trace of this interstitial compound we have done in the solid state also, and I have told you that how it will be. So these small compounds will get trapped in the interstitial site, and that's why they form interstitial compound. They're usually non-stoichiometric and are neither ionic nor covalent. And non-stoichiometric you have seen in the class in chapter 1. Yes, solid state. Example TiC, Mn4n, Fe3H, VH. Here you can see that it's not completely one. It's not like we cannot write. Here it is H जो है वो just 0.56. So that's why it is said that non-stoichiometric होता है. So these are the examples of the what we say interstitial compound. Properties of interstitial compound, they have high melting point, higher than those of pure metals. Pure metal से ज़्यादा हो जाता है because obviously the bond become strong. Yes, they are very hard. Some borides are as hard as diamond. So this is the point to learn. Some borides जो होते हैं, they are the interstitial compound. They are as hard as diamonds. Okay. They retain metallic conductivity, metallic properties इनमें रहती है still, and they are chemically inert because sites जो होते हैं वो completely filled हो जाते हैं, completely bond हो जाते हैं, and that's why strong होते हैं. So they are chemically inert. Okay, so now next slide is alloy formation. Alloy formation, that can be mixture of metals only, and that can be transition and non-transition elements also, mixture also. Okay, so mixture of metals like transition and non-transition, if they are, we can say that example copper and bronze. We have good example for this, brass and bronze. Brass is an example of copper and zinc. Here copper is transition while zinc is non-transition. Bronze is again copper and tin, where copper is transition and Sn is non-transition element. Okay. Similarly, it can be metal alloy like stainless steel, that means nickel, chromium, iron are mixed together. So that can be metal and metal alloy. Yes. दे आर वेरी हार्ड एंड हैव वेरी हाई मेल्टिंग पॉइंट. उनका बहुत हार्ड होते हैं एंड मेल्टिंग पॉइंट काफ़ी ज़्यादा हाई होती है बिकॉज ऑफ स्ट्रॉन्ग बॉन्ड. अगेन alloys are a mixture of metals to improve strength. Like alone iron has some demerits, like it can corrode easily, but when it becomes alloy, it becomes stainless steel, that corrosion property जो हो जाती है वो reduce हो जाती है. So it can improve its strength, its properties also. Example of alloy include gold jewelry. Like gold, pure gold jewelry cannot be formed because it is so soft, is easily move, मतलब मुड़ जाता है, टूट जाता है. So that's why in the gold jewelry, what we have to add, we have to add some silver to give it strength. Some shopkeepers they do this, they add like copper also. They can add brass also in that instead of this Ag. So okay, so basically that Ag should be added in the copper in this gold jewelry. Next is bronze. Again, the copper alone is it is having demerits of getting greenish. Yes, but if we add this tin in that, it is resistant to the oxidation. Similarly, copper and zinc for brass, sterling silver, that is copper and silver, is added in that. Okay. So these are few examples of alloy. So next slide is oxides and oxo-anions of metals. What are oxides and what are oxo-anions of metal? About oxides, let me explain you that there will be metal and oxygen only. Okay. But if we talk about the oxo-anions, that means it will be metal, oxygen with some negative charge. Or if it is not in negative charge, so like whenever we dissociate it that compound, that part on the then part left part, that means metal and oxygen jo bhi bachenge, on that there must be some negative charge. Like KMnO4 is a neutral compound, but when it dissociate it will give you MnO4 minus, so that is also called oxo-anion. Okay. I hope it is clear. Yes, chale let's see. They oxides and oxo-anions जो होते हैं, they generally form at high temperature except scandium. Second point, formed metal oxides can be ionic as well as covalent. दोनों हो सकते हैं. कब ionic होंगे, कब covalent होंगे, I will explain you. And the highest oxidation state in oxide is equal to its their group number. Got it? So जो highest oxidation state होगा वो उसके group number के बराबर होगा. Now example we can see that is scandium here +3, that means it is highest oxidation state should be equal to its group number. यानी कि group number से ज़्यादा वो oxidation state show कर ही नहीं सकता. Yes, less कर सकता है, less show कर सकता है, but high नहीं जाएगा. Got it? So here is scandium, we can see that it is +3 and group is that. Similarly Mn +7, group is that +7. V2O5 we can see +5, group is 5. TiO2 group is 2. Yes. So like this we can say. Now another compound also, like example if we see VO2 plus is also possible. So VO2 we see that oxidation state is 3. So it doesn't mean that जो oxidation state होगा वही group number हो. It doesn't mean that like it can show another state also, like VO2 plus if we see here vanadium is +3 state only. Yes. So it doesn't mean that whatever oxidation state it is showing that will show the group number. I said that maximum oxidation state will be equal to its group number. Less कुछ भी हो सकता है. Yes, okay. चलिए now next point. As oxidation number increases, ionic character decreases, and why this is, we can easily say this according to Fazan's rule. More charge on the metal, it will be more covalent. Yes, ये था. So less charge, less like covalent, that means more ionic. So we can say that as oxidation number, that means as positive charge increases, ionic character will decrease and covalent character will increase. So that's the reason that Mn2O7 is covalent. Got it? While Mn plus 2 is ionic. Acha, one important point is that the highest oxidation state, as the number of like what we say positive charge increases, that compound will be acidic. वो acidic होता जाएगा. Got it? Higher oxidation state, that means acidic. Lower oxidation state, that means basic. So these are the points that you have to write it somewhere. Okay. Example, like we can say that Mn2O7, when it reacts with water, when hydrolyzed, it gives HMnO4, that means plus 7 state here, and this becomes the acidic because it loses H plus and it shows the acidic nature. Similarly, we can say that CrO3 plus H2O, when it reacts, it will give you H2CrO4 or H2Cr2O7, where the oxidation state is plus 6, that's the maximum one. This is chromate and this is dichromate. CrO4 minus 2 is chromate and Cr2O7 minus 2 is dichromate. So in both the case, it is oxidation number plus 6, so they are covalent, but if I will ask about the acidic or basic property, they will be acidic. I hope it is clear. So in general, lower oxidation state metal, that will be basic. Okay, lower oxidation state basic, higher oxidation state will be acidic. Intermediate oxidation state, that will be called amphoteric. An example, we can say that MnO plus 2, so this is basic. While Mn2O3 is in plus 3, ये भी basic होगा lower में. But if we talk about highest one, Mn2O7, it is acidic. This is Mn3O4, this is MnO2, here it is in between, so that's why it will be amphoteric. Got it? Clear? Okay, now or one more point I should write over here, lower oxidation state basic, and along with that we can say that as and ionic, and higher oxidation state will be acidic and covalent. Okay, so you have a few more examples like scandium Sc2O3, this is basic, TiO3 basic. These are some examples, you can go through with that. Just a ZnO, although it is in highest state, but it will be amphoteric. So you have done few examples in class 10th only, that ZnO, lead oxide, zinc oxide, they are amphoteric in nature. Aluminium oxide, so these three are although they are in the highest oxidation state, but they will be amphoteric in nature. So few examples I have written over here. Okay, now that's it for today. So next we are going to do potassium dichromate and potassium permanganate, how they will be prepared and what are the chemical reaction, how they act. All these things we are going to do in next video. So till then, thank you class, enjoy your studies.